In this presentation, we will show you a comparative study of different machine learning classification algorithms based on the following plan. We start with an introduction, then the representation techniques. After that, we will discuss the numerical results, and finally conclusion. The classification or extraction of discrimination knowledge for a massive and heterogeneous data set surpasses the capacity of traditional database, which creates a lot of problems. To proceed efficiently, powerful technology such as machine learning techniques are needed. Now we move to support vector machine, SVM. The SVM is a supervised learning algorithm that classifies data in two or more classes. In the learning phase, SVM builds a model matches the boundary of each class and then specifies the hyperplane used to separate each class. Therefore, the optimal separating hyperplane maximizes the margin of training data. The next algorithm is k-nearest neighbor is a non-parametric algorithm which does not consider the distribution of data. It does have a learning phase. To classify a new input, the distance is calculated between this point and the k-nearest neighbor. The choice of k is an important key to success of this model. Now, we move to naive Bayesian. A supervised classification algorithm is used based on Bayes' theorem, with a hypothesis of the independence between attributes. In Bayes' theorem, the conditional probability that an event A belongs to variable B is calculated using this equation. Now, decision tree, a non-parametric supervised learning method. Initially, all training examples are at the root, divided recursively according to attributes selected based on an imperative function like information game. A decision tree structure is composed of internal node indicates a test conditional for an attribute. Each branch represents the result of a test condition. Leaf node is associated with a class label. The next algorithm is random forest. Random forest works by building multiple decision trees in the training phase. The decision from the majority number of trees is chosen by the random forest as the final decision. Finally, deep learning neural network. Deep architecture of successive layer, each layer apply a nonlinear transformation on the input, provided a representation in the output. The objective of the learning a complex and abstract representation of data is in a hierarchical manner by traversing the data with multiple transformation layers. Now we move to the numerical results. We implement the algorithms with Python using a real database. We compare the results with other methods in terms of accuracy, learning, and classification terms. We got the following results. The SVM achieved the best mean accuracy. We present a comparative study of the 6 most used classification algorithms in order to solve complex problems. It is necessary to take advantage of the strength of some algorithms to improve the weakness of others. Thank you.